So here is another question on electric dipole parameters. So it is given that 2-point charges of plus 3.2 into 10 to the power minus 19 coulomb and minus 3.2 into 10 to the power minus 19 coulomb are situated at a distance of 2.4 into 10 to the power minus 10 meter from each other and constitute an electric dipole. What is the work in rotating the dipole through 180 degree from the stable equilibrium position, okay, in a uniform electric field of 4 into 10 to the power 5 volt per meter. Okay. So here what is given is that we have an electric dipole with the charges minus 3.2 into 10 to the power minus 19 coulomb and plus 3.2 into 10 to the power minus 19 coulomb. The separation distance 2a is equal to 2.4 into 10 to the power minus 10 meter. Okay, and it is placed in an electric field of the magnitude of the electric field is equal to 4 into 10 to the power 5 volt per meter. Volt per meter, Newton per coulomb, same thing. So here the initial position is the stable equilibrium position. Stable equilibrium position means theta, the angle which the dipole makes with the electric field, is equal to 0 degree. In that position the potential energy is maximum. So here the dipole is to be rotated, the angle of rotation is 180 degree. Okay, 180 degree. So we know, so the concept which is used here, the formula which we will be using here is the work done in rotating the dipole. Okay, work done in rotating a dipole, that is equal to PE into 1 minus cos theta rotation angle. Okay, so P is the dipole moment, E is the electric field, theta is the rotation angle, which is here 180 degree. Okay, so here dipole moment P is equal to Q into 2a, which is equal to 3.2 into 10 to the power minus 19 into 2.4 into 10 to the power minus 10, then 1 minus cos 80 degree, so we will substitute here 3.2 into 10 to the power minus 19 into 2.4 into 10 to the power minus 10, then E, which is equal to 4 into 10 to the power 5, then 1 minus cos 180 degree. Okay, so here the result is, it is coming around 6.14 into 10 to the power minus 23 joules. This is the work done. Okay, so here the important thing is to remember this formula. Okay, all the formulas related to it. Okay, electric field along axial line, equatorial line, work done in rotating a dipole, potential energy of a dipole, torque acting on a dipole, All that formulas you should be completely aware of, and all these theoretical concepts we have discussed already. You can check the electricity and magnetism videos. Okay, so here is another question on electric dipole parameters. So it is given that an electric dipole consists of two charges of plus 16 into 10 to the power minus 19 coulomb and minus 16 into 10 to the power minus 19 coulomb, separated by a distance of 3.9 to 10 to the power minus 12 meter, and the dipole is placed in a uniform electric field of 10 to the power 5 Newton per coulomb. We have to calculate first the electric dipole moment and the potential energy of the dipole in stable equilibrium position. Okay, so here first we have a dipole the charge minus q plus q, where the magnitude of charge is equal to 16 into 10 to the power minus 19 coulomb. The separation distance 2a, that is equal to 3.9 into 10 to the power minus 12 meters. Okay, so first we have to determine the dipole moment. The dipole moment is equal to q into 2a, that is equal to 16 into 10 to the power minus 19 coulomb, into the separation distance, which is equal to 3.9 into 10 to the power minus 12. So that is coming around 6.24 into 10 to the power minus 30 coulomb meter. So that is the dipole moment. Then the stable equilibrium position. So here it is mentioned that the electric field E, the magnitude, is equal to 10 to the power 5 Newton per coulomb. So in stable equilibrium position, the angle between the electric field and dipole, that is equal to 0 degree. And the formula for potential energy of electric dipole is equal to, okay, potential energy of dipole in electric field, that is equal to U equal to minus PE cos theta. So here theta is equal to 0 degree. So here it is equal to minus PE. So it is equal to minus 6.24 into 10 to the power minus 30 into 10 to the power 5. So that is equal to minus 6.24 into 10 to the power minus 25 joules. That is the potential energy of the dipole in stable equilibrium position. Okay, so this is the thing. So again, here the formulas are very important. First, we have done many questions on this, okay, the dipole moment. This is the important formula here, which is potential energy of dipole in electric field and the concept of stable equilibrium position. Okay, okay.